Ladies and gentlemen, welcome to the next session of our tech session. For Q&A, kindly key in your questions at the Q&A chat box. Do visit our virtual exhibition and discover the latest water innovations and technologies. The exhibition will be live for 24 hours during this whole week. Do enjoy the next presentation.
Ladies and gentlemen, welcome back. We are in the Hall 3, Malaysia International Water Convention 2021. This is the 4th session. Upcoming topic will be developing a system management leakage plan by Mr. Gary White. Mr. Gary White is from Water. Gary White, a water consultant in Berhad, Malaysia. Over to you, Gary.
Thank you, Engineer Ko. Let me just start sharing my screen. Although I work for YF Water Consultants, I'm also working with IL Utilities as well. So IL Utilities is a consultancy company. It's originally from the UK, but they do have an Australian office that covers the Australia and Asia Pacific region. So I'm working with that out of that office, looking at the leakage and non-revenue water work, mainly in Southeast Asia, but also helping for some of the work in Australia as well. As I mentioned, IL's head office is in the UK, in London, but they also have offices in the US, in Australia, and in Singapore, and also in Europe as well. So they have quite a global footprint in terms of where they're based, and they also work with a lot of different water companies across the globe as well. As you can see, some of the utilities that we work with here on this slide. Now, what I'm going to be talking about today is the development of a system leakage management plan. And this is something that we at IL have been working on over the last few months, and we've actually implemented a couple as well. And it's all about managing your leakage. And I suppose here in Southeast Asia, or definitely Malaysia, we tend to call it a holistic plan. And it's all about managing the total holistic footprint of non-revenue water, all the way from your treatment plants, the output from your treatment plants, all the way down to the customer billing and revenue payment as well. So we're looking at the total non-revenue water across your entire distribution system. Now, we call it the system leakage management plan, more to do with the fact that most utilities, when they're looking at their non-revenue water, tend to have higher leakage or real losses than any other part of their system. And quite often this is down to the management of the pipe network and the assets underground, which tend to be aging, of poor material, maybe not maintained quite as well. So when we're looking at the system leakage management plan, we have actually decided to break that down into 9 different areas. And you can see those 9 different areas that we're looking at here. We've got non-revenue water balance, DMA reporting, active leak detection, pressure management, meter replacement, response time, digitalization, bulk metering, and asset management. All of these 9 areas, they have a key component of non-revenue water in terms of having to manage them properly will help you to manage non-revenue water directly as a whole. And I'm going to go through each of these 9 and just go in more detail about some of the areas that we've been looking at with these utilities. So the way that we go through this plan is the first step is to do a data gap review. Now, most utilities, or all utilities, they have sets of data, whether it's GIS maps, customer billing databases, or whether it's lists of assets that you have in the ground, asset databases, or even data logger pressure and flow data. So there's a lot of data that each utility has, and the first step for a consultant that is developing an SLMP is to actually review all of that data and to have a look and see how useful it is, and whether there's any areas that may need additional data or a bit of additional information. Quite often you can ask for additional information, and initially the water utility may think that they don't have that information, but when they start asking amongst their staff, they may find that there's 1 or 2 people that are keeping that data themselves, just for their own use because they find it easier. So sometimes going in and asking for this information can actually help to pull that extra data out of the utility itself. Sometimes it can just be a case of utilities not thinking too much about the data they have. We've worked with one utility in Australia, which was actually an amalgamation of several councils, and those councils had all been joined together to create one big water utility. And what actually happened was each of the original councils had different data sets. And when the water utility was created by combining those councils, the data was never really joined together, and you had better data sets in one old council with another council. So there can be reasons why data is not as good as it should be. But that's the first step, is to actually review this data and identify where you have data gaps so that you can hopefully get more data or ask the utilities if they can start to record that data. The next step is the analysis. Once you've got as much data as you have possible that's coming into you, being given to you, it's a case of then looking at the data across the 9 areas that I just described and trying to identify where the utility is performing well. For example, do they have very good GIS data systems? Do they have a lot of DMAs, and are they managing the data that's coming from the DMAs well? Do they have a good software program? I was talking to a utility this morning that had quite a few DMAs, but they didn't have any software to manage those DMAs at all. And they just basically looked at the data logger data on a monthly basis and determined which DMAs needed a bit of work. There was no real management of their DMAs. So it's the data analysis is looking to see what the utility is currently doing to manage non-revenue water itself, and identifying where there are weaknesses in their management programs. The third step is to then develop the SLMP. And this is basically a detailed report which outlines those 9 areas and what is being done currently by the utility, but also then creating a series of recommendations of improvements. What should be done by the utility to help them improve their non-revenue water? It's at this point that you actually need to start thinking about targets, because when we're managing non-revenue water, it has to be a long-term plan. You can't be looking at something which is just 1, 2, 3 years work. Quite often you're looking at non-revenue water programs that are 10 plus years in the management. And so what we're looking for is to see what sort of target the utility should be aiming for over, let's say, a 10-year program. That could be the economic level. A lot of utilities that are down, that already have been managing their non-revenue water quite well already, will be starting to aim for their economic level, which can be achievable within a 10-year period. But if you have utilities whose non-revenue water is currently high, I mean 40% and above, then maybe they're not going to make it to the economic level within 10 years, but we need to work out what sort of targets we can give them to achieve that over the 10 years. The recommendations that we would give would be things like increase active leak detection, install more PRVs, maybe do advanced pressure management, more pipe replacement, all of the standard works that need to be undertaken to manage your non-revenue water. And quite often utilities will know what they have to do or have an understanding of what they have to do. But having a plan like this, which is developed, which states quite clearly what needs to be done to achieve the certain targets, helps utilities to get clearance from their board or whoever is funding the works to say, okay, we need to do this. This is why we need to do it. Let's do it. And as part of the SLMP, we would also develop a 10-year investment plan. And this plan is like a spreadsheet showing all of the different recommendations and all of the ongoing activities that are already being done by the utility, detailing the costs that would need to be covered each year for those 10 years to achieve that target. And of course, if you know what your 10-year plan is and how much investment is needed over those 10 years, you can then look at the cost payback to say, okay, we're going to need to invest 100 million ringgit over the next 10 years, and it's going to pay back 20 million ringgit per year. So it's a 5-year payback after the end of the program, or maybe partway through the program. So that sort of cost benefit analysis really is useful for the investment plan. Now, why is IOL sort of like key to doing this, or what sort of other programs do we have that help us to develop a very good SLMP? We actually develop a number of benchmarking programs. So IOL has a leakage management benchmarking program, an asset management benchmarking program, and also a digital utility maturity program. All three of those benchmarking programs look at some of the areas that we would look in the SLMP, such as the leakage management, asset management, digital management, and comes up with where a utility sits, benchmarked against other utilities. And those utilities would be international utilities as well. Some that will be the same size as the utility we're looking at, but some might be smaller, some might be larger. So those benchmarking programs give the utility an idea of where they fit amongst their peers. But the information we get from the benchmarking program can also be used in the SLMP to help us identify where a utility should be heading to. We also have a civil maintenance benchmarking program. This program is mainly in Australia, so it doesn't really give us too much in terms of costs for, say, Southeast Asia. But we do have things such as repair times, response times, how to do traffic management, what sort of labor, materials and plant would be required. So the civil maintenance benchmarking program does help us in that respect as well. Another program that IOL runs is called WLab, or in the UK it's called TAG, and it's a technologies program where utilities can sign up and they then have access to a database of thousands of different technologies. So if a utility is looking at, say, a new technology for water quality testing, then they can go onto the database and they can actually view whatever technologies we have on our database. So with the database of different technologies, it's useful for IOL to be able to recommend some of those technologies if we feel that some of them would be useful in the SLMP to help manage non-revenue water. And the other area, of course, is the access to the IWA Water Loss Specialist Group. I'm actually the secretary of the IWA Water Loss Specialist Group, so I have very good contacts with a lot of NRW specialists across the globe. So we can start to ask other people for support and technical advice as well if needed. So that gives you an overview of why IOL is ideally placed to be able to develop these SLMP documents. So if we look at the 9 areas that I was talking about, we can start with non-revenue water first. And one of the key areas for any utility to be looking at is the non-revenue water water balance, which was developed by the IWA. It was actually the IWA Water Loss Task Force that started to develop the water balance, and you can see it here. This was about 20 years ago, and the task force was actually a breakaway from another specialist group in IWA called Efficient, and this task force then became its own specialist group about 8 or 9 years ago. And what the non-revenue water balance is doing is it's looking at taking your system input, which you can see on the left. You've then got your billing, and it takes that off, and it then works out what your non-revenue water is in terms of a volume. But not just that, it actually looks to break down the different components of non-revenue water. And this is key because when you're a utility, you need to understand what all of these different components are so that you can identify which ones have got the biggest volume, biggest non-revenue water volume, and thus which ones will give you the biggest payback. You may find that your biggest NRW component could be meter under registration, which would seem to point out that your meters are inaccurate. Maybe they're old and need replacing, and that could be a program that you could put in place. But generally, with most utilities, you will find that it's actually the real losses: leakage on transmission and distribution, leakage and overflows at storage tanks, and leakage on service connections. These tend to be where the biggest losses are in terms of non-revenue water volume. But if you can break it down between distribution, transmission, storage tanks, and service connections, you can actually then target where you do your NRW management better. For example, one utility that we did an SLMP for, we actually identified, and you'll see in a minute, that most of their leakage was on the service connections. So this meant that we could identify that they needed to start investing more on replacing service connections to ensure that they weren't leaking too frequently. One of the things with the NRW water balance is that there are some areas that need a bit of estimating, and these can be you can either use the IWA assumptions, which you can see here, which is the dashed gray lines on the two graphs, or as you can see from some of these utilities here, each of these from A to M is a different water utility, and this is part of the leakage benchmarking program. So you can see where some utilities just use the IWA assumption, whereas others try to make a better estimate of how much unbilled, unmetered, authorized consumption is. Unbilled, unmetered is going to be things like firefighting, watering, tankers filling up, watering of gardens, that sort of thing, mains flushing. These sort of areas will account for your unbilled, unmetered. And you can either use the IWA assumption, which is what a lot of utilities do, or some utilities do is they start to try and make estimates based on how much flushing operations went on, how many tankers they think were filling, how many fires. Sometimes they can get the fire brigade department to actually tell them how much water they think that they used. And you can start to develop some estimates like this. So there are two different options here. And under the SLMP, we sort of do a review of your estimates, how these assumptions are made. The same with unauthorized consumption. So this is like theft. And what we're looking at here is to try and identify how much theft there is. Some utilities feel that it's quite low, so they just use the IWA assumption. But we once again have some utilities that try to estimate real figures or try to get a better handle of how much theft they have in their system. So what we're trying to do with the SLMP is review how the utility is estimating these, and then develop some recommendations on whether they can improve on how they do the estimating. The real losses, as I mentioned, this tends to be one of the key components of non-revenue water. And what we want to do is we want to try and break it down into the different areas, such as service, reticulation, trunk mains, and reservoirs. Some of it can be easy. So from reservoirs, we should have a good idea how much leakage we think we have from our reservoirs, and it does tend to be fairly low most of the time. If a utility has a lot of DMAs established, they can work out quite quickly what is the leakage on the trunk mains compared to the leakage in the DMAs based on flow balancing. So if you have a distribution zone with a number of DMAs in it, you can maybe take a flow meter on the inlet to the distribution zone, minus the DMAs will give you some leakage levels in the trunk main. Then what becomes more difficult then is looking to break down between reticulation, distribution, and service pipes. And often this is done by records from leak reports. So if you have a leak report database, it should give you information such as whether the leak was on a main or if it was on a service pipe. Based on that percentage and information, you can then work out what the split is between service mains and reticulation. As you can see, this is the one I was talking about before, which is a utility we developed an SLMP for. And you can see that the majority of the leaks is on the service mains. And this was a problem, a couple of problems really. One was the pipe material they were using for their service mains. They originally started with PE50, then they started on PE80, and they found that both of those materials were not strong enough for their system. So they've now started to change to PE 100. They also had an issue with the ferrules where they were buying cheap ferrules to connect the PE into, and they found that cheap is not always best, as we know. So they've had to change the ferrules that they used for a better quality one, which will ensure a better and stronger fit to the PE 100 mains. DMA reporting. So most utilities, especially in Southeast Asia, will have a lot of DMAs, district metering areas. And as I mentioned before, once you start to get hundreds, if not thousands of DMAs, you need to have quite a sophisticated monitoring system that's actually going to be automatically looking at the data, all of the data within the flow and pressure within those hundreds or thousands of DMAs every day to actually analyze which DMAs need to be looked at in terms of real losses first, because that's the easy one, and then also apparent losses. So real losses can be estimated based on night flows. So if you have a flow meter, which is measuring and recording flow going into a DMA, you can actually look at the night flow. So you can see here where the flow drops down at night. We assume that most of the customers are asleep, so there's not much use at night, but there will be a small amount of use, which you can see this minimum night consumption. And then that gives us a net night flow. And by looking at this net night flow, we can actually determine which DMAs have got higher leakage, which ones have got higher net night flow, and thus which ones have got higher leakage levels. And that then enables us to identify which DMAs we need to go in and do active leak detection. With these softwares, we can actually have target levels, intervention target levels. So these target levels are a net night flow level that when it reaches that level, it creates an event, which means that it tells the operator that they need to go and start to do active leak detection. Now, I mentioned that in the SLMP, we actually have to identify an overall holistic target for the utility. And that can generally be in terms like liters per connection per day. So what we can do is we can, using the number of connections in each DMA, we can work out what the intervention level is, working backwards from the company-wide target from the net night flows. Once you've worked out roughly what your real losses are inside the DMA, you can then work backwards and say, okay, if I know what my real losses are, and I know what my total non-revenue water is inside the DMA, then I can subtract one from the other and get an idea of what the apparent losses are in each DMA. And with this, it would help you to understand whether you've got meters that need replacing in that DMA, or maybe they're just, maybe there are some customers which are missing from the billing database that need to be added to the billing database because they're not reported correctly. Active leak detection is the next step. So based on the analysis that we've just talked about in the district metering areas, it's then a case of saying, okay, we need to go out and do active leak detection. This is to physically go out and to look for those buried leaks. Everybody knows that there are leaks that come to the surface and are often reported by customers. And that's good because it helps us to identify those easy leaks. But that means that there are many more buried leaks which don't come to the surface that we need to find before they just keep leaking out and wasting water over a long period of time. And that's where we need to start doing active leak detection, which is where we have people going out looking for those buried leaks underground. Of course, we've got to balance between how much it costs to do this active leak detection with how much water is being lost. There are some utilities in, let's take Australia, for example, where they don't actually do much active leak detection. And this is because their tariffs are a lot higher, which means that they do a lot more pipe replacement work because they can afford to. And so they don't have as much leakage. And then you also have other countries like in Southeast Asia, where they may not do as much active leak detection because the tariffs are so low. And if the tariffs are so low, this means that the value of the water that's being lost through the leaks is not so great compared to the cost of hiring a lot of leak detection technicians and engineers. So each utility is different, and it's a fine balance between how much do I spend on doing active leak detection against how much am I going to save from the water that I'm going to stop leaking through the pipes. Another key thing to address is the trunk main leakage. If you remember when we looked at the non-revenue water balance a few slides back, it showed that one utility in Australia had 9% of its leakage was on trunk mains. Now, a lot of utilities will try to say that their trunk mains don't have much leakage. And this is often because doing leak detection on trunk mains is quite difficult. And to do it properly and effectively, you actually need to spend quite a bit of money with some very good equipment that's specially designed for finding leaks on trunk mains. And therefore, a lot of utilities will just claim that they don't have any leakage on their trunk mains. But it's probably true to say that most utilities will have leaks on their trunk mains. I know every utility that has done leak detection on their trunk mains has found plenty of leaks without trying too hard. So trunk main leakage is something that is always recommended when we're developing a system leakage management plan, and it's often because utilities are not doing it at this time. Pressure management. So this is a real key component of managing real losses. It's probably the most cost beneficial way of controlling leakage volumes, because by putting a PRV on and maybe an advanced PRV controller, you can manage pressures in a system. You can also manage the leakage volumes in a DMA and also the burst frequency in a DMA. So you're actually saving leakage water volume, but you're also reducing your repair costs from the number of bursts that you have. One of the key things when you're looking at pressure management is to look at the N1 calculation. So this is basically how leaky your system is compared to pressure. So normally it's like a root curve here, which is like a 1-to-1 curve, which means if you reduce your pressure by 10%, your leakage volume would come down by 10% as well. But these days, with a lot of systems that have plastic pipes and even some of the older AC pipes that crack rather than burst, those cracks will, as pressure increases, the crack gets wider and wider, which can actually increase the leakage volume by more than a square root volume. So sometimes you can reduce pressure by 10% and leakage volume will reduce by 15 or even 20%. So getting that N1 calculation right is critical for you to be able to do your cost-benefit analysis for doing pressure management programs. A lot of utilities are already doing pressure management, putting PRVs in place. In some places, it's probably not so much of a case in Malaysia or anywhere in Southeast Asia, but firefighting flows can be critical, especially if firefighting systems are fed directly from the mains. I think mainly in Southeast Asia, most of our firefighting systems go into a tank first, and then you have pumps that pump into the system. But in places like Australia and even the UK, they actually have firefighting systems that feed directly off of the mains. So you have to be aware of that as well. Meter replacement is a key one. We all know that meters age, and as they get older and older, their accuracy starts to decline. So we need to have a proper meter testing program in place so that we can then identify at what age we need to start replacing our meters. Is it 7 years? Is it 8 years? Is it 9 years? So we need to have a proper meter replacement plan in place. And this can be cost benefit again to see how much it's costing us to buy and install a new meter compared to how much we're losing on the inaccuracy. But this is a key part of any NRW program. But also it's important because it increases the revenue for the water utility, which is how we're going to help pay for some of these NRW programs. A key thing is the large customers. Quite often you'll find that under 1% of your customers will account for something like 10% of your revenue. And that is critical, that you then have to manage that 1% of your customers and make sure that the meters that you're metering them with are some of the most accurate, maybe electromagnetic meters, and that you have data loggers on them so that you're getting information back daily, so that if anything happens to those meters, you can go out and fix them as quickly as possible so that you're not losing any revenue. Response time. So we've talked about active leak detection, going out and finding those buried leaks and even the visible reported leaks. We need to be repairing those as quickly as possible, and to make sure that we are not losing water that we know about from these leaks. From our benchmarking program, you can see some typical responses where some water utilities are reporting, up here of nearly 500 hours to repair a leak, down to an average around here of about 200 hours. But we do have some utilities in certain parts of Australia where they have drought conditions, where they basically want to be repairing their leaks in 2 hours. So they have very strict response times to make sure that if it's a priority 1 leak, it needs to be repaired within 2 hours. Digitalization. So all utilities are looking to improve how they digitalize their system, whether it be customer meters, data loggers, flow and pressure monitoring, GIS, all of this information. So what we tend to do with the SLMP is look at the current digital programs that are in place and to see how they affect the NRW and how they're going to benefit from it, but also then start to recommend some technologies, digital technologies, such as monitoring on trunk mains, so that you're finding out how much leakage you've got on trunk mains, digital metering, so that you're implementing AMR, AMI systems, which may help you to get more frequent customer data that's coming back. All of these digital programs can help with the non-revenue water. But of course, once again, they all have a cost benefit associated with it. Bulk metering. This is your metering at your treatment plants or in some cases, this can be the water that's being sold to you. So it's critical. When we looked at the NRW water balance, you saw we started from the system input on the left. And this is the measurement of your system input. And it's making sure that you're measuring the water that's coming into your supply system as accurately as possible, whether it's from a treatment plant, which is being managed by your utility yourself, or whether it's coming from a third-party bulk supplier. You really need to make sure that your meters are as accurate as possible, that they're being verified electronically and volumetrically on a yearly basis. And if necessary, doing some flow balances to check that they are accurate. Sometimes people use insertion probes to install downstream to check the volume that's going through the meters. And the last of the 9 programs is the asset management. And what we're looking at here is what the problems are in the system. So it could be service pipes, it could be your reticulation pipes, it could be down to material, it could be down to age. If you look here, this is one of the graphs we did for one SLMP where we were looking at the service pipes and how the number of failures increases with age. And you can see that when we get to about 35 years of age for these pipes, you can see there's a big increase in failure rate. We're not quite sure what happened after 70 years, but there's probably not many meters that make it, many service pipes that make it that long. But what we're looking for there is to say, okay, when you start to get to 35 years of age, that's when you need to start considering service pipe replacement programs. We also look at different technologies. So here we've got stainless steel, flexible stainless steel technology. At the moment, it's still expensive. It's probably about 5 times as expensive to buy the material as PE, but it will last a lot longer. So if you have PE services that are lasting 40 years, your flexible stainless will probably last you about 80 years, so twice as long. And we've also got some no-dig technologies. This is one where they actually drag a liner through the service connection, and they can line a service connection that's even 25 millimeter in size to sort of cover up any holes that you have in your service pipes. And it's important to understand how much mains replacement and service pipe replacement or rehabilitation that you need to do. If you look here, you can see that the purple dots that we have here are actually the ILI, which is the Infrastructure Leakage Index. The lower the index, the better the way the utility is performing. And it's just sort of showing you that if you're spending a lot of money on mains replacement, you're actually going to get lower ILIs generally. The ones that are not spending so much have got higher ILIs over here. This one's a bit of an anomaly, that they're not really doing much mains replacement, but they've got a low ILI. And that was really down to the fact that it's quite a young utility and a small utility, so they didn't have to do too much mains replacement there. So all of this analysis that we do for all of these 9 different areas, we develop a very detailed report. You can see here that this report is over 100 pages long, and it details a lot of information such as the current background of the system, the water loss management basics, and it goes through the different areas such as pressure management, all the way to the investment plan as well. The investment plan itself, as I mentioned before, is quite a detailed spreadsheet, and it gives you how much needs to be invested over a 10-year period for each of the different activities that are ongoing. Some of these activities would actually be already being done by the utility. So if we look at active leak detection, you can see that there's this was already being done, but maybe we're recommending that it's increased. Or maybe there's something completely new, like metering of fire flow connections. So that would be an additional cost as well. But what comes out of this is a detailed 10-year investment plan showing how much needs to be invested in total over the 10 years so that a utility understands how that would work. How do we undertake the program? We, first of all, we have a kickoff session, which we call Workshop 1, which is where we talk to some of the key utility staff to discuss with them the different elements of the program. Then we have a second workshop, we do the data gap review, which is we review the data to try and understand where there are missing areas. Then we have workshop 2, which is where we discuss those data gaps with the utility, and we also talk to them about some of the analysis that we're starting to find from the data. Then we produce a draft SLMP with a number of recommendations to the utility, which then ends with a third workshop where we once again go through all of the different recommendations to see whether it needs fine-tuning or whether the utility agrees with us or disagrees with some of the recommendations we're making. Once we've finalized all of those recommendations, we then develop the 10-year investment plan and the cost-benefit analysis, and we finally produce a final SLMP report, which is handed over to the utility for them to review and probably build up to a board paper, which can then be used for investment. So there's a number of deliverables in terms of reports. So we produce a data gap report, we produce a data analysis report, and then we do the final SLMP report, and we do the spreadsheets that are coming from the investment plan as well. And just as a final thing, the development of the SLMP will actually take probably about 12 weeks or about 3 months work, but it does depend a lot on the size of the utility, what the data is like that they're sending us, and how many programs they've already got in place. But on average, it's probably around about a 3-month program to develop a good quality system leakage management plan. So that's the end of my presentation. I hope that's given you an understanding of how we go about developing a system leakage management plan and how it can be helpful for a utility to actually manage their non-revenue water and to have better aims going forward in terms of targets and what they need to do that. Thank you.
Thank you, Gary. We open up to the floor to take some Q&A. Okay. There's one question from Mr. Ishaq Hasnan. The question is, one of the assumptions in NRW is the inaccuracy of water meter. Normally 5% to 6% estimated loss due to the inaccuracy of water meter. Is there any study been done to prove that the figure is correct?
Yeah, so a lot of utilities will actually do standard meter testing. So what they do is, let's say you have a utility that has maybe 100,000 customers. They will take a sample number of meters out of the field and they will take them to a test lab to be tested. This can be a test lab in the utility itself. So if it's a large utility, they may have their own meter testing facility, or they might go to a third-party testing company. I know in Australia, they do tend to use some of the meter manufacturers like Itron or Sensors, where they can do their testing for them. But you should normally have a sample, a percentage sample that you sample every year, just to check the accuracy of your meters. And based on that, you can then work out what your program of replacement should be.
I have one question, Gary.
Yeah.
The NRW thing is it's very challenging to move on, to implement, to keep it ongoing. I think for Malaysia environment, because of the low water tariff, which is not portray the true value of the tariff, is not the true value of the water. Now, your experience with so many international other part of the world, what is the so-called sustainability of this NRW, the baseline, whereby what kind of tariff we should look at, and what kind of the reasonable NRW? Is the NRW something like for a human being to take vitamin, to certain sickness you can cure, but when beyond that, it'll be too expensive for you to keep on. If you don't keep on, the NRW go back again. So what have you done is all the waste. So you have to start all over again, and the tangible benefit is not very clear. This is where I think we have in Malaysia. What is your comment again?
Yeah, it's every utility has what we call a economic level of leakage, or economic level of non-revenue water. And it's basically, as I said, a balance between the cost of the water that's being lost, so the value of the water that's being lost, against how much the utility is spending. And so when you're talking about non-revenue water, the value of water lost is easy. The value of work being done includes everything like pipe replacement, meter replacement, DMAs, leak detection and repair, all of that work. And you have to do a balance between the two. Now, to say how much of a tariff you should have, it's not that easy, because each country will have different costs. So, for example, if you compare Malaysia with the UK, the cost of replacing a pipe in the UK is going to be a lot more expensive than replacing a pipe in Malaysia. But there are some costs which are similar, like the cost of equipment. The cost of a data logger is almost the same price in Malaysia as it would be, say, in Australia. So there are some costs that are the same, but there are others which are more expensive in other countries and cheaper here. So every utility, there has to be that balance for you to say, okay, what is our economic level? And I do know that there are a number of utilities in Malaysia that have already done that balance. So they already know what their economic level is. But that economic level is based on it's based on the current tariffs. So, and there are a couple of utilities that actually got their non-revenue water down to a point where they were probably below their economic level. So it wasn't economic for them to do too much more. So they stopped and the level started to come back up again. Now, if tariffs are increased so that the value of the water that's being lost increases, it means that those utilities will have to relook at it again and say, okay, now it's economic for us to go lower. And that's where utilities, because of the revenue side of things, because you're trying to manage the revenue, sometimes when you're doing some of the work like pipe replacement or buying meters or buying equipment, you don't necessarily buy the best, but you want to use your money as efficiently as possible, so you don't necessarily buy the highest price pipes material, or you don't necessarily buy the best leakage equipment, but you buy the ones that you can afford. So by increasing the tariff, you're actually giving utilities a chance to have higher revenue, which means that they can spend it on better equipment, better services, which will help to manage the NRW over the longer term, definitely. One of the other issues that we have in Malaysia is there's quite a few utilities that are not cost self-sufficient, which means that with the low tariffs they don't actually have enough money to do a lot of the work that I've just outlined.
Right.
So the only way that they can do a lot of the NRW management, such as pipe replacement, DMAs, active leak detection, is to get federal government funding or some sort of funding. It normally comes from the federal government. And the only way to change that mindset is to increase tariffs so that these utilities become cost self-sufficient, so that they can actually start to manage the system properly, rather than trying to almost beg for money every year to put into place some programs.
Yeah.
I hope that answers it a bit.
Yeah. I think that is very frank opinion, I would say. You know, and hopefully, as what the Dato' Sri Secretary General was mentioning just now, that within 100 days there is something good changes in the water tariff in Malaysia that will at least keep the water supply industry moving on. I think we desperately need to look at all these issues, because it's not only NRW itself, there are some others, water safety plan, things together. I think all should come in, as what you said, holistic. There's no more question, Gary. I think we have to conclude this sharing. Thanks a lot for your time. We hope to see you again in some other platform with all your good expertise and knowledge. Thank you, Gary, and thank you to all the participants in this whole tree. Thank you very much.
Thank you.
Yeah.